Hello guys, and welcome back to another episode. In this episode I'm going to be looking at building a DIY MCP. Now the reason why I'm not going straight in with a HISPA panels one, as you can see in front of me here, this is the open cockpit one, that's fully built and working. This is the HISPA panels one, and I have made a DIY one on the CNC machine. The reason we're not going for this straight away is because I'm getting so many requests on how to program and how to wire up an MCP, and we'll just use this to explain the process. Of course, if you're going to make this yourself, you would obviously paint it, or you'd print it out and use Perspex. I'm using MDF because it's what I've got ready available, and it's done. It's CNC machined out, it's ready to go. Hi guys, for me this is post-editing. Now this video is exceptionally long. Unlike other videos where I can fast forward all the boring parts, the boring parts had to stay in because perhaps you need to see how to program correctly. So to negate that extra long process and you having to watch the whole video, I'll put timestamps in and just look in the description below, and hopefully you can jump to the section that is relevant, or the section that you need to see. I get asked a lot of questions now, which is my favourite design, the open cockpits one up here or the HISPA panels one right in front of me here. Now just holding the HISPA panel one in my hands compared to the open cockpits one, open cockpits is my favourite. It's got a better engraving level, it's got all the corners are rounded, so it has a better aesthetic look. Now I've never seen a real 737 MCP, so I have no idea what to confirm it to, but for the general pleasing aesthetics, my open cockpit is my favourite, but I'll hold out the final decision until I've actually built this, because this might be a more complete solution. In this episode I'm hoping to concentrate on getting the 7 segments fitted and working, and I'll show you how to program that straight away. And I should state at this point that not all 7 segments are created equal. There are some bad ones, there are some good ones, and I imagine when we go to fit 5 sets of 7 segment displays on the Mach 7219 boards, we'll probably find some dodgy ones. Let's put this thing together. This time around on this build, these are just purely from the trash bin, or the gash bin as we'd like to call it, and these are just random components. So we have 14 push button switches here, all with LEDs in, your standard mini toggle switches, standard LEDs, and these are the blue backed PCBs for the 7 segment displays called Mach 7219 boards. On my first sim, I did like to use these buttons, just because you could pull the Perspex cover off and then place the printed label inside. They were quite a good alternative, and I also prefer these kind of Mach 7219 boards because they separate, which means you can have one display over here and one display over here. They don't have to be next to each other. So first up is to install all the header pins on these 5 7 segment display modules. And this is what the MCP now looks like. So the first thing I have to do is plug the Arduino in. Just going to plug it into my hub and my test rig. Green light comes on, and then we'll load Mobiflight up. So the software we have running right now is Prosim Server, Mobiflight, Prosim MCP, and hidden in the corner on this screen down here is PPAR3D. There's one more thing we need after we've got the software set up, and that's a list of the configuration for each switch, for each indicator, each encoder and each 7 segment. Now if you don't know how to program, if you're not sure of a certain setting, this whole MCP settings list will be available on the website from this point on. These are my settings, these are my personal settings. You can adjust them as you see fit. So it starts off with switches, but we now need to progress to the later section. Here's the config page for the 7 segment displays. With the software ready, the Arduino ready, let's wire the first 7 segment display up. So here's our first 7 segment display. Here's the input right in front of us. The top pin is 5 volts positive. We use red for that. Next pin is ground. Next pin is DIN. I'll use orange. The next pin is yellow, which is chip select. And the last pin is clock, which is green for us today. In and secure. With the wires fitted to the first 7 segment display, let's help them up to the Arduino. Looking at the offsets page, we know that we need pins 45, 46 and 47. Now you can see from my Arduino here that I already have the brown wire going into the ground and running into the breadboard on the parallel bus along here. So all these pins on the top row are ground, and the same for the 5 volts positive coming from the top of the Arduino into the positive rail of the breadboard. That means I can have a lot more connections than that's possible from the Arduino. So the first 2 to connect from the 7 segment display are the ground and positive 5 volts, which is simply, it's going to slot in there. And we know that the orange is DIN, which needs to go into 45, pin 45. Yellow is pin 46 and green is pin 47. With the unit all wired up, it's now time to program it. We're going to head into Mobiflight and set it up. We're going to tell it what pins it's using and what is connected to those pins. So first of all, we head over to Mobiflight, we go to the Extras tab, we go to Settings. Up to the Mobiflight Modules tab, select our Arduino in the list, and then I want to add device. Today we're using 7 segment displays, and we need to tell it what pins are attached to those displays. And today, as you can see from our config file, it's going to be pins 45, 46 and 47, and the number is the amount of 7 segment daisy chained in a row. We've got 5 on our MCP, so I'm going to change that number 1 to 5. Then we need to upload. Yes, we do. And click OK. So now that we've told Mobiflight what is attached to the Arduino, we now need to program that line. So I'm going to type in here MCP Captain's course. I'm going to edit the line, and if you can see from the screen, we're actually on the MC course value, which is down here, and we need the offset 530 alpha. 530 alpha. It is an int. Yep, size in bytes is 2. And then we need to click across to the display tab. We need to select our Arduino. It is a display module. It's the number 1, and it's going to be the first 3 digits of that display. So there are 8 digits, and as you can see, 1, 2, 3, 4 and 5 are hidden. That leaves us 6, 7, 8 on the first module. We're going to use left padding, and it's going to be full of zeros. If we click test, we get a nice 1, 2, 3. Now that's always a good start, being able to see that. So now that we've programmed Mobiflight, we need to tell Prosim what values to expect. So we head over to the Prosim server, open the config tab, into configuration, and the first thing that you need to check is under drivers, and that is to make sure that you've got FSU IPC enabled. And that's this big line here. If that's ticked, we're good to go. Head over to the combine config, into MCP, and we are using numerical. I'm going to scroll down to the MCP course value. Here it is here, and it's 16-bit signed. I'm going to enter 530 alpha and click OK. Back over to Mobiflight, hit the active tab and then hit run at the top. Nothing's happened, and that's pretty standard for 7-segment displays. You have to stop, file, save, and I'm going to shut it down and restart it. Just wait for it to load up, bring it across. It's still ticked. Now if I hit run, you can see that we've got 0 on the 737 Prosim MCP, 0 showing in the FSU IPC, and the output value is 02, and it's also displaying 0 on the display. And if I adjust the value on the MCP, the value now changes on the real MCP. And there we have our first 7-segment display setup. We're moving on now to the indicated airspeed Mach numerical 7-segment display. Nice and simple, no wiring, it's straight into Mobiflight and Prosim config. New line and edit it. MCP IAS Mach. Edit it. This time I'm going to use the offset 5310. Still in. This time it is 4 bits. The display is the Arduino display module. It's still number 1. This time it's the last 3 digits. Use left padding. That's too good. I'm going to stop. Click OK. Head over to Prosim, configuration, combine config, find the numerical we want to adjust, which is the speed. This time it's going to be 32-bit signed, and we're going to enter 5310. It's OK. I'm going to tick the box. I'm going to stop Mobiflight, and then I'm going to hit run again. And we're in. So if I go down to the MCP and adjust the indicated airspeed, just the knob, and there we have it. 150 no problem, all the way back down to 100. and it was as simple as that. Nice and easy, nice and quick. 2 done. Next up is the heading display. Now that is going to require some wiring. We need to make some jumper leads to go across, and we'll do that now. I want to jumper just 3, or should I say, I want to daisy chain 3 of the 5 lines. And that's going to start with the orange, which is DIN. So out on this side, in onto the other side. Let's put that on the right one. Finally green, which is clock. Now with the last 2 pins, the power and ground, they require their own wires. Because you cannot daisy chain the power or the ground lines. In goes the ground, in goes the power. Straighten them up. It's now time to program Prosim and Mobiflight. Here's the settings for the heading. So I'm just going to enter those into the computer and we'll see what we come up with. So first up, edit the line, and it's going to call MCP Heading. Go to the end, hit the button, and this time enter the offset 530 echo. And the size in bytes is 2. Into the display, select the Arduino in the display module, but this time it's number 2, and I'm currently using digits 5, 6 and 7, the rest are hidden. 5, 6 and 7, and hopefully you better see this. If I hit test they should display, and they do, which is a big bonus. And then hit OK. I'm going to highlight the line to make it active, head over to configuration in Prosim, combine config, back to MCP and into numerical. Find the heading, there it is. This time it's 16-bit signed, and enter 530 echo. As easy as that. Hit OK. I'm going to hit stop on Mobiflight, and they're going to hit run and see if it works. And we have 0, 0, 0. Going down to the heading indicator, and all I'm going to do is adjust it. And as you can see, we now have full control of the heading display. And we'll leave it at 300. That's the heading complete. I'm going to flip it over and do the altitude next. It's the same as before. We need the 3 shorting links to complete the daisy chain, starting at orange, and that goes from the DIN out of the last one into the DIN in of the next one. Yellow is chip select, and finally green as the clock. Connect our power and ground up. There goes the ground. Put it on the right chip. There we go, secure. And once again, we need to put the ground and power into the buzz. So all the power is running in parallel. That was a quick wiring session. Straight back into Mobiflight and Prosim. MCP altitude, hit the edit button, I'm going to enter the offset 5306, it's a 4-bit code, into display, select the Arduino module, this time it's number 3 and we are using digits 2, 3, 4, 5 and 6 and 7 in fact. I'm going to hit test. So I've switched it off test, I've switched OK. I'm going to activate the line and then head over to Prosim. Hit the configuration. Again, combine config, straight down to MCP, numerical and find the altitude, which is right at the top. It's 32-bit signed and we know the offset is 5306 and hit OK. These should be now talking. I'm hoping, because we've just restarted Mobiflight, I can just push run and nope, I'm not that lucky. So once again, yes, save configuration, I'm going to restart it. Let's try hit run this time. Bingo. Apart from the fact I have one too many noughts. So if I go into edit, display and use left padding. In fact, I also want to switch off the naught in front, so it's going to be space. And let's see what happens now. Brilliant. All working. So if I adjust the altitude now on the MCP, you can see that it also indicates. Perfect. Now it's not quite right because we don't have the 0 in front. So what I need to do is I need to go back into the edit. I'm going to switch off the last digit, which is number 2. I'll put that back to 0. And now let's see what happens. Good. So if I was to go to 2000, 2000 matches and it's got the 0 in front. All the way up to 10. We're way past it in fact. Let's stick with 11. 11 is good. And of course the highest you can go is 50,000 feet. Perfect. It's a matter of repetition. Flip it over, put the wires on and reprogram. Let's start with the vertical speed next. That's got a few extra tabs that need to be extra data put in. So as before, it's just a simple case of daisy chaining the 3 data lines. And then applying the power and ground lines. And plugging them into the parallel bus bar. And we're done for the next set. Straight back into programming, Mobiflight first and then Prosim. Edit a new line, I will call this MCP vertical speed. Hit the button and our offset will be 5314, size in bytes is 4, This time we need to go to the Compare tab and apply comparison to the current value, hit the tick, pull the menu down, the drop box, and hit equals, and if it displays -1, we want the display to be blank. So all we're going to do is hit the spacebar 6 times. 1, 2, 3, 4, 5, 6. Onto the display tab, we're going to hit the Mobiflight Mega, the display module. This time it's number 4, and I'm only using digits 2 to 7. But that's 6 digits, and I think we only need 5 for vertical speed, so I'm going to remove the 2. I'm going to use left padding, and it's going to be with zeros. I'll go to test, but nothing will happen, that's fine. Over to Prosim, into config as standard, configuration, combine config, straight down to MCP, into numerical, and look for the vertical speed. Drop down menu, I think this is going to be 32 bits signed, it is, and again enter the offset 5314 and hit OK. I'm now going to close Mobiflight. I do want to save the changes and reopen it. And now it should reset the Arduino. Make sure the line is active, so we've ticked it, and then we're going to hit run. So we still have no vertical speed indication, but again it's not showing anything. I go into test, display. Ooh, it worked for a fraction of a second and then dropped out. The reason why it only worked for a fraction of a second is because I believe the program was running at the same time. So I'm going to tell it to stop, back into the display, and then hit test. Now it should stay alive. As you can see, it's worked. And we've been extremely lucky to get 4 daisy-chained 7219 boards working without any hassle. I'm going to hit stop, click OK, and then hit run. To get that to display, I'm going to switch the flight director on, hit VS, and we've got it good. Up 7,000, minus 7,000, perfect. And it goes blank. Number 4 done. As you can probably guess, flip it back over and rewire for the last digits.
Okay, let's do the last 3. Same as before. Let me see if I can hold the board a bit sturdier so it doesn't move around so much. Now a quick note on the links. I do like to try and make the joining cables between the display boards as short as possible. The longer you have them, more chance errors will creep in. And of course, now that those are connected, we need our power cables. Red is top for me. There we go. And then we're going to plug them into the buzz bar off the breadboard. And it's as simple as that.
The last section, the final set of digits. Let's see if we can get there without any hiccups. Straight into Mobiflight, double click the line, and I'm going to enter MCP First Officer course. Hit the edit button, and the offset for me today course is 530 Charlie. It's 16 bits, so that's just 2 bits. and straight to the display. 2 bytes, sorry, not 2 bits. Set the mega, the display module. This time it will be number 5. And the digits are going to have a quick look. Are 7, 8, 6, 7, 8. 6, 7, 8. Zeros. I'm going to hit test, but it's not going to work. Stop. Because the program is running in the background and I haven't restarted it since entering the new digits there. I'll make the line active. Over to Prosim for the time being. Configuration. Combined config. MCP. Numerical. And then we're going to scroll down. It's the only one we haven't done, and that's the MCP course 2 value. I'm going to select FSU IPC 16-bit signed and enter the same offset value of 530 Charlie. And hit OK. Of course, I'm now going to restart Mobiflight. It should ask me to save. It does. Coming across, there we go. I'm going to hit run. So it is working, but we have gobbledygook. I'm going to stop the program and then we'll test it. So it looks like we've got the centre line missing from each digit. There had to be one bad one, and that normally means that we've got an issue with the actual board itself, because it's the centre line that's missing. It's not a data error. So what we're going to do temporarily to prove it, I'm going to take the input to test the board itself. I'm going to take the first input, the first 3 leads that are connected to the Arduino, the orange, yellow and green. I'm going to unplug them from the first board. I'm going to strip them away from the power lines off the first board. Yeah, it's not going to like that. So I'm going to disconnect all the power lines to the other boards. I'm going to remove the shorting links, not shorting links but the data links, and we're going to plug straight in. So, orange first. Spin these round. Then yellow, and then green. So now all we're connected is the first board. I'm going to hit stop on the Mobiflight module, there we go. Then I'm going to deselect all the active lines. I'm going to make a new row, and that's going to be First Officer Course Test. I'm not going to put any values in, I'm simply going to display module. It's number 1 because it's connected directly to that module now. And it's 6, 7, 8. And test, okay, stop, okay. I'm going to exit out because I've changed the values and it needs to reset them. Reload Mobiflight. Drag over that. Edit the First Officer Course test line into display and hit test. And there we have it. We actually do have a bad 7-segment display. We can do a bit of fault finding to try and get that to turn up. Hopefully it's just a bad soldering joint. We're going to take the board off the back of the MCP and see if the other digits are working. Annoyingly, I only actually have 5 sets of this type of 7219 boards. And we can have a look at the problem. Just going to gently flex the board. Oh yes. We definitely have a bad connection. Oh. and there's the problem straight away. I'm going to unplug it because it's going to need servicing. Okay, so if we look at the left hand side of the screen, you can see that there's lovely soldered joints, and if we look at the right hand screen, but now which is in the centre, you can see, come on, focus, there we go. I have absolutely no idea what has gone on, and that has come straight out of the packet. They look completely corroded. Right, well, let's see what we can achieve. So with our corroded and damaged display board, I'm going to have a quick look to see if we've got a spare, but I don't think we have. This seems to be all I've got, but we'll just double check before I go to the hassle of resoldering all the pins. Let's have a quick look. Well, that's confirmed it. Not even my little gash pot has got a spare one in. So I'm going to head over to the workshop, try and resolder the tabs and see if that gives us a better result. So back in from the workshop, where you've just seen me do a quick resolder of the pins. The actual pads that you solder onto look damaged, as if they're either corroded or missing, and I've had to put a lot of solder on. So I'll do a quick test and see how that looks.
Okay, I'll hold it there.
Head down to the test button and hit test. While I never. 1, 2, 3, all fully working. 2, 3, 4, 5. So I'm going to test the whole board now. And it works. I can't believe that worked. So that is a Brucey bonus.
Get them the right way round, that's for sure.
And now I'm going to hit run and see what we get. And there we have it. It's actually all up and working, which is a bit of a shock because it's never normally gone that easily before in the past. Now let's just try and change the course. That's brilliant. I'm going to switch the VS on as well. There we go, vertical speed. Make a quick adjustment and get rid of that last 0, hopefully. Will it let me do that? Oh no, we definitely need to do that. Use left padding. Let's make it a space and see what happens now. There we go. Good. And if I go to minus, yeah, the minus works. Let's go down to 300. 300 on this side. Indicate airspeed 120, that works good. 245 down to 240, and let's take it down to 10,000. -5 minus, there we go. So there we have programming of the 7-segment displays. A little bit of fault finding, but we got there in the end. And that has now allowed us to connect 5, or daisy chained 5 7-segment boards just using 3 cables. Let me get the fingers right this time. 3 cables to provide all that data to the MCP, which is great. Now normally you're probably wondering why I just didn't wire it all up to start with and just go for it in one go. Now that would have been a lot quicker. However, if there had been any faults like I was expecting to see missing digits, I was expecting to see dropouts in between the lines. Normally, as you saw on the last one, when we got that missing digit in the middle, The only reason why I thought it was a wiring fault was because it was missing on the test as well as the program when we clicked run. Sorry. If that had been okay on the test, then I would have suspected rogue data as we're going down the line. And normally, I find that we need an external power source to provide data for that many 7 segments for reliability purposes. Especially when we start connecting the encoders up, we'll probably find in the next video, as soon as I go to adjust the encoder, all this should go, I don't know what that was, but all this should go to gobbledygook because the current draw is too much, and then we get data corruption on the 7 segment displays. Excuse me one second while I stop the other camera from taking random photos. The whole purpose of this other little doodah on the breadboard here was to provide an extra 2 amps of power if we needed it for the 7 segments. In this video we don't. In the next video when we do the encoders, so we can adjust the values on here to change the values on the MCP. If we start to get dropouts, we'll just reroute the power from the 7 segments directly to the external power supply, which should solve all our problems. It's that simple, it's that easy. So until next time guys, I'll catch you later. Sim out.